Good day, grade 10s. Welcome. This is the new year and we're starting off with algebraic expressions. But before we get there, we're going to look at the number system and that which you are already familiar with. Just remember, this resource is copyright protected. Unlawful use of the content can lead to prosecution. Material is not to be sold or to be used to make money. So let's start with the number system. Where did the number system originate? The first people that taught you about numbers were your parents, or your brothers or sisters or other siblings or family or relatives, and they taught you to count, and they taught you count for me 1, 2, 3, 4, 5, and that is exactly what you did. And once you reached counting to 5, they expanded the numbers and said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you mimic this. And because this is a natural system of teaching learners or children how to count, we call these numbers natural numbers. And the symbol for natural numbers is the letter N. Then you went to school and the teacher asked you to count. And in the class there were a number of learners that had their hands up to 1 to count. And then the teacher asked this child next to you, a little bit unsettled, you were upset that the teacher did not ask you because you could also count. And when the learner started to count 1, 2, 3, 4, 5, the teacher said, no, we don't count like that. We count 0, 1, 2, 3, 4, 5. And there was the number 0 that was thrown in now. That was a new ballgame. And then you felt like, I laughed at this child that got it wrong, but that's not what we should do. We should encourage others to do the right thing. Then the symbol for whole numbers is then N with a 0. And this 0 means that it's natural numbers plus the 0 that is added to the natural numbers. The following set of numbers we call integers. And these are positive numbers and negative numbers, including the neutral number 0. 0 does not have a positive or a negative sign tied to it. It is neutral. 0 is a neutral number. Then we have positive and negative integers. The symbol for integers is the letter Z. Now we will look at the number system. The number system consists out of two main categories of numbers. Firstly, we get real numbers, that is numbers that exist, and we get non-real numbers, numbers that does not exist. The symbol for real numbers is the letter R. The symbol for non-real is R dash. What numbers fall in this category of non-real numbers? This is numbers that is divided by 0. Can be any letter or any number that is divided by 0 is non-real. You type it into your calculator and press equal, your calculator will display error. Also, any third form of a negative number, any square root, fourth root, sixth root, eighth root of a negative number will give you a non-real, it's called an imaginary number, but it's non-real. Then, real numbers is divided into two categories. Rational numbers and irrational numbers. The symbol for rational numbers is the letter Q, and the symbol for irrational numbers is Q dash. Now, irrational numbers is numbers that cannot be written as a fraction. And this includes third forms that does not have a real or a rational solution. For example, the square root of 1, that has a real solution, which is 1. The square root of 4, which is 2. The square root of 9. The square root of 16. They are all rational numbers, but the ones that is irrational will be the numbers that fall between them. For example, the square root of 2, the square root of 3, the square root of 5, square root of 6, square root of 7, square root of 8, square root of 10. Remember, 9, square root of 9 is 3. So that one does not qualify as irrational. And also any other surd. For example, your cube roots, the cube root of 8 is 2, and the cube root of 1 is 1. So between 1 and 8, the cube root of 1 and the cube root of 8, you will find the cube root of 2, the cube root of 3, the cube root of 6, the cube root of 7. They are all irrational numbers. And then there's also a special one, which is pi. Pi is irrational. It's a non-ending, non-recurring decimal. So all these answers, if you type it into the calculator, it will give you a non-ending, a non-recurring decimal, and therefore they are called irrational numbers. They cannot be written in the form of a fraction. Rational numbers, however, there's 4 categories. The first one is whole numbers, meaning any number that can be written in the form of a fraction, meaning in the form of a over b, as long as b is not equal to 0. Remember, when something is divided by 0, we get non-real. So then, therefore, a whole number is, for example, 4 is a whole number, can be written as 4 over 1, 4 wholes. So therefore, whole numbers. Likewise, 57 can be written as 57 over 1, which is also 57 wholes. So that is a whole number. Then common fractions. And here we can look at a half, a third. As long as the denominator is not 0, any common fraction, 25 over 100, 225 over 1,000, a quarter, a third, you name it. Any fraction is deemed as a rational number. Then ending decimals. Ending decimals meaning 0,25, 0,875, 0,225, meaning the decimal ends. If it's 6 decimal places, it ends after 6 decimal places. So therefore, it can be listed as an ending decimal. So 0,25, if I have to rewrite that as a fraction, that will be 25 over 100, and I can simplify that further as 1 over 4. 0,875 can be written as 875 over 1,000. So that can be simplified to 7 over 8 in simplest form. Then we have 0,225, which will be written as 225 over 1,000. These are ending decimals, and here you can see it can be written as a fraction, and the denominator was not 0. Then we also have a fourth type, and that is recurring decimals. For example, 0,1212 want to be successful in mathematics, or 0,3 recurring, meaning 0,3333333, and I think that one is very familiar already. You know that that is a third. And then you get 0,11, which means from, and with a little line on top of the two numbers, that means both those numbers are repeated. So that will be 0,11111111. So in our next lesson, we will look at how we can rewrite these numbers, these recurring decimals, as common fractions. Just to briefly take you through them, I want to show that 0,121212 will be written as 12 over 99 and can be simplified to 4 over 33. 0,3333333 is a third, and 0,11111111 is 1 over 9. Thank you for watching this video. I trust that the explanation served you well. For help or assistance with mathematics, feel free to get in touch with me. My contact details are displayed at the bottom, and you can also track it on YouTube with 4IR, Fourth Industrial Revolution, or Nth Industrial Revolution. So, thank you for watching. Hope to see you in the next video.